Hey guys, I'm here to get you started on the thermoenergy problems. Today we're going to be focusing using the MCAT equation. All right, so you can tell I just kind of picked a few out from the assignment, not all of them, because you're going to do work on your own. All right, so number one says a 2 kilogram mass of water in a beaker has its temperature raised by 3 degrees Celsius. How much heat has been transferred to the water? And then it gives us a specific heat of water. Okay, so we know we're using the Q equals MCAT problem. Okay, remember that Q is the heat energy, M is the mass, and we've been using kilograms. C is the specific heat. And delta T is the final temperature minus the initial temperature. Okay, so the change of temperature. All right, so here this tells us a mass of 2 kilograms. It gives us the specific heat of 4,180 and all those units that I'm not going to write out. And it tells us the change of temperature is 3.0 degrees Celsius. All right, so we have everything we need, and then it's asking us to figure out how much heat was transferred. So I am going to do that. I'm going to do 2 times 4180 times 3, and that tells me that we have 25,080 joules of heat has been transferred to the water. Okay? So number 2 is very similar to that. You got that. Number 3, a 1 kilogram mass of water whose temperature was 50 degrees Celsius lost 33,600 joules of water or of heat. What was the final temperature of the water? Okay, so let's see. I'll write it out like we're used to. Mass is 1 kilogram. The initial temperature was 50 degrees Celsius. The heat lost was 33,600 joules. And then it's asking us to find the final temperature. Okay, so the only thing it doesn't have here is the specific heat, which is given to us in this first problem. For water, it's still the same, it doesn't change. So if we do Q equals MCAT, but instead of doing the AT part, I'm going to do the final temperature minus the initial temperature. Okay, now I'm going to plug in my numbers, and then we'll go from there. All right, let's see. Okay, and since it says it lost the heat, this is going to be negative, by the way. All right, so negative 33,600 is equal to 1 times 4,180 times the change of temperature. So we're looking for the final temperature, but our initial temperature was 50 degrees Celsius. Okay, so we're going to solve this. 1 times 4,180 is 4,180. So to move it to the other side, we'll divide by 4,180. So negative 33600 divided by 4,180 is equal to negative 8.0. We'll round that up to 4. Sorry, I didn't do a good job spacing my writing, but that's going to be equal to x minus 50. So now I'm going to add 50 to each side. So plus 50 to this number. Okay, and that's going to give me a final temperature of 41 point, we'll round that to 42 and just leave it at the whole number 42 degrees Celsius. Okay. Again, sorry for that looking so messy. The final answer should be 42 degrees Celsius. Okay, and again, the reason I put a negative here is because it was 50 degrees and it lost heat, it lost energy. So that means it's cooling down. So that makes sense that my final temperature is lower than my initial temperature. Okay, so if it loses heat, you want to make sure that you put a negative in front. All right, number 4, working out the same way. So you got number 4. Again, just make sure, is it gaining heat? Then it's positive. Is it losing heat? Then it's negative. All right. Let's see. So number 5, the specific heat of aluminum is 890. Is 890. A sheet of aluminum foil is put into the oven and has a temperature change from 21.7 degrees Celsius to 84.8 degrees Celsius by absorbing 475 joules of heat. What is the mass of the foil? Okay, so we know the Q, because it tells us that it's 475. We know the specific heat for aluminum is 890. Sorry, I'm being a horrible example by not writing out the units. Joules per kilogram degrees Celsius. The initial temperature was 21.7 degrees Celsius. The final temperature was 84.8 degrees Celsius. And then it's asking us to figure out the mass. Okay, so when I plug this into the problem, okay, so 475 is equal to M, because that's what we're looking for, times 890 times the change of temperature. So final, which is 84.8 minus 21.7. And we go from there. So let's see, I can go ahead and solve this side. So 890, or we'll do the temperature change first. So 84.8 minus 21.7 was 63.1. So now I'm going to do 63.1 times 890. So that gives me 56,159. We'll say M for the mass is equal to 475. So divided by 5,006. I can't talk today, I apologize. Divided by 56,159 on both sides. 47.5 divided by 56,159 gives me 0.008. We'll just do one sig big here. Kilograms of aluminum. Okay, so a small piece of aluminum, but it's also in kilograms, so it would be 8 grams of aluminum if I did the conversion. Okay. So if you're looking for mass, this is what you do. All right. Hint for number 7, because it's not a math problem, it's more of a do I get this kind of problem? Look up the definition for specific heat. Look what we talked about specific heat within the notes, and then use that to come up with your answer. I know that you guys are smart enough to be able to come up with an answer for that. Okay. Number 8, is a calorimetry problem. Says a 4 kilogram iron ball at 225 degrees Celsius is placed in water at 4 degrees Celsius. When the system achieves thermal equilibrium, the temperature is 40 degrees Celsius. What is the mass of water in the container? Okay, and then it gives us both of the things. So I'm going to kind of split this up into two. Okay, the first thing is we're going to figure out iron, the Q, or how much heat was lost by iron because it's cooling down. All right, so for that, we know iron's mass is 4 kilograms. It tells us that the iron's specific heat is 450. And then the initial temperature of the iron was 225 degrees Celsius. The final temperature of the iron, okay, when it reaches equilibrium, is 40 degrees Celsius. Okay, this 4 is what water started at. So we'll use that in a second. Okay, so I'm going to use this and I'm going to put it into the MCAT problem. So 4 times 450 times my change of temperature. So 40 minus 225. Scoot that up a little bit. Plug it in. Oops, sorry, desk is sticky. Gross. Times 450 times. Okay, so the Q for iron, negative 333,000 joules. All right. Because they're getting into the iron and the water, like the hot ball of iron dropped into the cool water are reaching an equal temperature in the end. Okay, that means that water is going to have the same amount of heat transferred, but this one's going to be positive because it's going from cold to hot. All right, this one went from hot to cold. Water is going to be going from cold to hot, so it's the positive version of it. Okay, let's see. We don't know the mass. Let's see. We do know the specific heat for water. Joules per kilograms degrees Celsius. We know that the initial temperature of water was 4 degrees Celsius. And we know that the final temperature is 40 degrees Celsius. All right, so this is what you need to solve now for the mass, which is what we did up here with number 5. So I'm going to let you guys finish number 8 because I know you can do it. You don't need me to do it. You might want me to do it, but I know you can do it on your own. So I'm going to make you a better, stronger student by doing it on your own. Okay? The challenge question at the end of the worksheet is just that. It's a challenge problem. It's not worth any points on the assignment, but hey, if you can figure it out, it's going to make you that much better. So I encourage you to try the challenge problem. All right. Again, hopefully this helps you out. If you have any questions, ask us. All right. We're here to help out. We want you to do well. All right. Keep working hard, guys.